Let's take a look at an integration by parts technique where my integral gets easier, but I still might not be done. So for this problem, I'm going to consider z as my variable. So I'm integrating z squared times e to the power z. And once again, I think of this as the product of two different functions inside my integral. Their derivatives are not related to each other, so I can't use a u substitution. Instead, I gotta use integration by parts. So I'll have a u and I'll have a dv, and the integral will be replaced by u times v minus the integral of v du. I'm going to pick u equals z squared so that du equals 2z dz. So I know that this is actually going to be a lot simpler to work with than this part. E to the power z times dz, well, that's my dv. And since e to the power z is its own antiderivative, that's also my v. And the question is now, I can do this substitution, but is it actually an easier integral than what I started with? U times v gives me z squared e to the power z, and I subtract off v du, the integral of v du. I'm going to write this as 2 times z times e to the power z times dz. Is this a simpler integral? Yes, it is. Do I know how to solve it? Well, not written this way. I don't. I will need to use integration by parts for the second time. So let me write the integral which I wish to solve. This is round 2. I'm trying to solve for the integral of 2 times z e to the power z dz. And I'm going to use integration by parts again. Again, I'm using my polynomial as the u. If I take that derivative, it'll be simpler. So my du will be twice a dz. Once again, dv is equal to e to the z dz. V is going to be e to the power z. And this is supposed to be equal to u times v minus the integral of v du, like so. So when I fill out my recipe card there, u times v, I will write as 2z e to the power z. Subtract off this integral. The integral I get is this. So, is this an easy integral? Well, yes, yes it is. But more to the point, this is an integral I actually can do just by looking at it. So I would say that my 2z e to the power z, that's going to come along for the ride. And I need to subtract off my antiderivative here, which I know is going to be twice e to the power z plus some constant of integration. Okay, cool. I've finished round 2. I can take this answer and put it back in the formula for the problem I'm actually trying to solve. This is my two-parter. So, the integral of z squared e to the power z dz is equal to z squared e to the power z minus this integral. But But we just figured out what that integral is equal to. I'm subtracting off the integral of 2 times z times e to the power z dz, and I know that that integral is equal to this formula. So really, I'm subtracting off 2z e to the power z, and I'm subtracting off a 2 e to the power z plus some constant of integration. And I need to distribute that minus sign the whole way through. So the answer for this integral is going to be z squared e to the power z minus 2z times e to the power z plus 2 e to the power z plus my constant of integration.